Before December 2021, astrophysicists operated with a standard, accepted rulebook for how the universe grew. We relied on specific models that explained the formation of galaxies and the steady expansion of the cosmos from its infancy. Instruments like Hubble gave us breathtaking views of space, but their optical lenses were physically blind to specific wavelengths of light. This left vast chapters of the cosmic story hidden behind impenetrable clouds of dust. The James Webb Space Telescope changed the perspective. Using massive gold hexagonal mirrors, Webb was engineered to see deeply into the infrared spectrum, capturing light that has been traveling for over 13 billion years. But as soon as the first data beamed back to Earth, astronomers hit a wall. When they analyzed the results, they realized their foundational models of the early universe did not match the reality Webb was seeing. These initial data returns have invalidated established growth timelines, requiring a total reevaluation of how the early universe matured. To find the source of the discrepancy, we have to look back 13 billion years to the cosmic dawn, an era just 300 to 500 million years after the Big Bang. The baseline expectation for this era was relatively simple. Standard models predicted we would only find small, slow-growing, cold gas clouds just beginning to form the very first stars. This chart illustrates the surprise. On the left are the predictions, small, scattered star clusters. On the right is the reality Webb captured, massive, intensely bright, and fully mature galaxies thriving in an era where they shouldn't exist. That rapid growth extends to supermassive black holes, too. Webb discovered that objects like the black hole in galaxy UHC-1 had already reached massive proportions far earlier than previous astrophysical models allowed. The early universe was not a slow, quiet nursery. It was a chaotic and highly efficient engine for cosmic construction that contradicts our previous timelines. While Webb looks back at deep time, it is also focusing on our localized galactic neighborhood, scanning exoplanets located just light years away. Through transit spectroscopy, Webb captures starlight filtering through a planet's atmosphere to read its chemical fingerprint. On Waterworld K2-18b, this confirmed carbon dioxide and methane. Most notably, the spectrum showed dimethyl sulfide, a compound produced on Earth only by living organisms. Webb can also prove the absence of an atmosphere. By mapping surface heat emissions on LHS 3844b, the telescope showed it to be a dark, hot, barren rock resembling Mercury. Webb has transformed exoplanet hunting from merely counting distant shadows into directly assessing alien geology and searching for potential biological markers. Historically, massive clouds of cosmic dust have acted as a shroud, permanently hiding the birth and death of stars from our view. Webb's infrared cameras are designed to cut straight through these dense, leaden-hued dust lanes, revealing what's happening inside. In the Pillars of Creation, Webb's infrared view makes the dust nearly translucent. Thousands of newly hatched stars become visible, emerging from their nebular nursery. This view also clarifies the end of a star's life. In the Southern Ring Nebula, Webb captured an expanding envelope of gas cast off by a dying system. The infrared sensors penetrated the core of the nebula to reveal a previously obscured second star, a dying red giant shedding the outer layers that created the nebula. By cutting through the cosmic dust, Webb has given humanity the ability to witness the complete hidden life cycle of stars for the first time. Capturing the infrared spectrum allows Webb to document cosmic history that remained physically inaccessible to every telescope that came before it. The overarching lesson from these early missions is clear. The universe is more dynamic and efficient at creating complex structures than our old textbooks claimed. Webb is only at the beginning of its operational lifespan, with decades of data collection yet to come. We are witnessing a period where the standard cosmological timeline is being revised in real time as the deepest history of our universe finally becomes accessible.